Hi, welcome to Sachin Study Tech. Today topic is single source shortest path. So single source shortest path problem aims to find the shortest path from a source vertex to all other vertices in a weighted graph. The two most commonly used algorithm for solving this problem is Dijkstra's algorithm and Bellman-Ford algorithm. Now in this video we can explain about Dijkstra's algorithm. So what is the Dijkstra's, where you can apply the Bellman, where you can apply the Dijkstra's algorithm. So first you can discuss about the Dijkstra's algorithm here. So Dijkstra's algorithm can work on both the directed graph and undirected graph. So what is meant by directed and undirected graph? For example, you can see here, this is the vertex A, this is the vertex B. So this is a graph. So you can take, this is a edge. So edge weight is, for example, here it is 5. So either you can write A to B or B to A. So there is no direction. Okay, this is a undirected graph. So either you can write A comma B is 5 or B comma A is also 5. You can write. So for example, you can see A to B. So there is a direction A to B. So in this case you can write A to B only. A to B is 5. There is no B to A. So you can write here A to B and B to A. Either you can write A to B or B to A. So there is no direction here. That's why this is a undirected graph. Either you can write A to B or B to A. But in case of here it is both are equal. A to B or B to R is equal. But in this case A to B is 5. For example, you can consider B to A is, for example, here it is 6. So A to B is 5 and B to A is that is 6. So there is a difference. So this is a directed graph. There is a direction between one vertex to another vertex. Here there is no direction. It is an undirected graph. It is directed graph. So in Dijkstra's algorithm we can apply which is a undirected graph and directed graph also. So here it is. At this algorithm designed to work on any type of graph, that is directed and undirected graph, as long as it meets the requirement of having non-negative edges. So the weight must be positive. Okay, then only can apply the Dijkstra's algorithm. If the weight having any negative weights is there, then you cannot apply the Dijkstra's algorithm. So that is the drawback of Dijkstra's. So given weight graph and source vertex 2 in a graph, find the shortest path from the source to all other vertices. For example, here it is a graph is there. So A to B, here it is C and here D. So these are the four vertices is there. So I am consider A is a source vertex, then you have to find out A to B and A to C and A to D. So this is the source vertex. You can find out all other vertices. Okay, then you can find out the which is the shortest path. So you can see, you can discuss here the Dijkstra's algorithm. First initialize the set the distance of the source node is 0 and all other nodes to infinity. All other nodes to infinity you can set it. So now you can pick the current node, select the unvisited node with the smallest distance and update the neighbors for each neighbor of the current node, that is calculate the new distance as current distance plus edge weight. If the new distance is smaller than the current stored distance, update it. Mark as a visited, mark the current node as a visited. Repeat, go to the step 2 and until the all nodes are visited. You can see this is the example. So here there is a rule is there, go on relaxing all the edges n minus 1 times, where n is the number of vertices. Relaxing means, what is meant by relaxation? Relaxation means updating the shortest distance to a node if the shorter path is found through another node. So that this is the formula. If du plus c of cost of uv less than d of v, then d of v is equal to, you can update the d of v equal to d of u plus cost of uv. Now you can see this is the example graph here. You can, it is a undirected graph, there is no directions. So now we can apply the Dijkstra's algorithm by using greedy method. So here it is, you can find out the path to A to B, A to C, A to D, A to E and A to F. First step is, step 1 is, so here this is, I am considering A is the initial vertex. Now it is marked as 0, remaining all vertices is infinity. Remaining all vertices are infinity. This is the first step. So you can see what are the vertices is there. Vertex A and B, C and D and E and F. These are the number of vertices is there in that graph. Here it is visited vertex. So here it is visited vertex. For example, in the first case is, I am consider A is the source vertex. You can take any vertex as the source vertex, but I am consider A is the initial vertex, source vertex. Then, so it is 0. Remaining all vertices are infinity. Now we can select the shortest vertex. So here is the shortest. So I am consider this is the shortest vertex. Then A is a visited vertex. Now A is a visited vertex. Then have to find out A to all other vertices. Now we can see the next step is A to B. So A is 0, B is infinity. So A to B is 4. So you can see here, for example, it is U, it is V. If D of U, so D of U is 0 plus cost of UV that is 4 less than D of V. What is the D of V? It is infinity. If it is condition is true, then you can update D of V equal to D of U plus cost of UV. That is equal to, what is the D of V here? 0 plus 4. So we can update it. Now we can update that value here. It is 4. Now we can see A to B is 4. And also like that, here also you can apply the same thing, same formula. Here it is 0, here it is 5. A to C cost is 5. Now it is infinity. So 5 is the minimum. 0 plus 5, 5 is the minimum. You can update it. So you can update A to C is 5. Now you can see, is there any edge A to D? There is no direct edge. So it is infinity. And there is no direct edge A to E. It is also infinity. There is no direct edge from A to F. It is also infinity. This is the second step. You can draw the second diagram also. But I am considered this is only one diagram. I am modified here. But you have to take the number of steps. The first step is it is a 0 and remaining all vertices are infinity. You can draw the diagram. And second step is here there is a direction here. So you can connected edges there, direct connected edges. A to B you can update it, A to C, and there is no edge from direct edge from A to D and A to E and A to F. So that's why these all are infinities. So you can draw the second diagram. Now we can check. So which is the minimum here? Which is the minimum vertex? So here it is 4 is the minimum vertex. 4 is the minimum vertex. So that's why I am visited, first visited A is I am visited vertex here. Now I am visited B vertex. So B vertex I am visited here. So you can visited vertex, note down this B in a visited vertex B. Now we can see the distance between the B to D and B to C and B to E. There is a link, there is a edge from B to D, B to E and B to C. Now you can use the same formula here. The B is 4. Now B to C. So what is the value here? Here it is 4. 4 plus 11, 15. But already 5 is there. So this is a small. You can leave it. So you can leave it here. It is a 5 already. This is a small. Then you can see here it is 4 plus 7. That is 11. Already infinity is there. So 11 is the minimum. So you can update here. You can update Here B to E is 11. Now you can see B to D. So B to D 4 plus 9, that is 13, but already infinity is there. So 13 is the minimum. So you can update it 13. So here it is 13. Now you can see B to F. So there is no direct link to B to F. There is no direct edge. So it is a infinity. It is infinity. So what is the minimum vertex here? Minimum cost vertex. So this is the minimum vertex. Now C is visited vertex. Now the C is visited vertex. C is visited vertex. Now we can see what are the edges is there, C to B, but B is already visited, so we cannot change it. And C to E, C to E is here it is 5 plus 3, 8, but already E is 11, so 8 is the minimum, so you can update it. So E is the 8 here. Next one is, next there is no edge C to D and there is no edge C to F. Then so F is the infinity and there is no link C to D. So what are the value is there in D? So 13 and remaining 3 vertices are visited ABC. Now you can choose the minimum weight cost of the vertex here. So E is the minimum. Now consider here it is a E. E is the visited vertex. Now you have to find out the distance between remaining E to D. E is also visited vertex. E to D and E to F. So E to D. So 8 plus here it is 13, that is 21. Already 13 is there. So that is the minimum 13. If it is F is infinity, that is 8 plus 6. 8 plus 6, that is 14. So 14 is the minimum. You can update it. 14. It is a 14. You can see here. It is a 14. Then which is the minimum? These are two are unvisited vertices. So which is the minimum? So 13 is the minimum. You can choose. So D is the visited vertex now, and you can update the D to F. These are already visited vertices. Now you have to D to F you can find out. D to F. D value is 13. 13 plus 2, that is 15. But already 14 is there. So 14 is the minimum. So 14. Then for example here you can see D to F and D to, here it is 13, 13 plus 13, 26, 26 plus 6, that is, so here there is no direct link, but we have to check this distance also via E, that is 13 plus 13, 26 plus 6, 29, but here the 14 is the minimum, so 14. So this is the visited vertex now. So all vertices are visited. What is the so distance between A to, so A to A is 0 and A to B is 4 and A to C is 5. The distance is 5, and for example here you can see A to B is 4 and A to C is 5 and A to D is 13. A to D is 13 and A to E is 8 and A to F is 14. So how can get the 14 here? A to B, here it is 4. So that is A to B directly. A to B edge is there. So A to B. Now How to get A to C? This is also direct. A to C, it is a 5. Now you can see A to D. So A to D, how can get the 13 here? It is a 5 plus 11, that is 16 plus 9, it is more than that. So 4 plus 9, that is 13. So it is A to B and B to D. So that's why it is 13. Next 8, A to E is 8. So 5 plus 3, 8. So that is A to C and C to E, that is 8. And 14, 5 plus 3, 8, 8 plus 6, 14. So that is A to C and C to E and E to F, that is 14. So you can find out the distance between all other vertices, but we have to draw the each and every step. You can draw the diagram. So that is the important. Time complexity is big of V plus E. V is the number of vertices, E is the number of edges, log V, where V is the number of vertices and E is the number of edges. Here the space complexity is big of V plus E. So you can use the efficiency matrix, that is vertices and number of edges is equal. For example, it is big of V square. So this is the space complexity of this Dijkstra's algorithm. So time complexity is V plus E log V. So this is the time complexity. Thank you for watching this video. Next video you can discuss about. So you can consider the directed graph. Then you can find out the shortest path, single source shortest path, okay, by using greedy method. Thank you for watching this video.